This tutorial is an introduction to algebra. We talk about what algebra is and how it works. Some students find this introduction a little bit tricky. There are some examples at the end. I just want you to remember that even though you might struggle with these examples, the next tutorial will be easier. It sounds silly that they get easier, but this tutorial has a lot of language in it that you might find a bit confusing. But remember, the whole thing about this tutorial is you can rewind and watch it again, or just skip back a few seconds and watch again if you don't understand something. What is algebra? You've heard this word. You've seen it in cartoons even. People always talk about algebra. Because a lot of people struggle with it at school. It's not really that hard if it's explained properly. Algebra is that branch of mathematics that talks about rules or formulae. Formulae is the plural of formula. You guys know what a formula is. It's that part of mathematics that talks about relationships between numbers that change. Now, that might be a bit confusing, but we're going to do an example now that will help you understand that. If only 4 people are allowed to travel together in a car, how many cars would be needed to transport 387 people? Now, I'm not interested in the answer here. How would I write that algebraically, or as an algebraic equation? Do you agree that the number of cars that we would need would equal 387 divided by 4? Clearly. What if there were 568 people? Number of cars would be 568 divided by 4. And if there were 986 people, number of cars would be 986 divided by 4. So can you see this number here always changes? And when it changes, this number changes. So this talks about a relationship between this number and that number. This doesn't change. You could write it like this. Number of cars equals number of people divided by 4. I'm sure you'll agree with that. But a slightly better way. Use the letter C for the number of cars, the letter P for the number of people, and divided by 4. Sorry, I think I might have said plus 4. Divided by 4. Number of cars equals number of people divided by 4. Now, in algebra, we try as far as we can not to have multiplication or division signs. So instead of writing P divided by 4 like that, we tend to write it as a fraction. So we got rid of that division sign. So number of cars is number of people divided by 4. Now you might see that some people, because they like to have the first letter of whatever it is they're talking about as the variable, might put number of cars equals the number of people divided by 4. I'm just showing you this so that you kind of get the idea that you can just about do almost anything. But I think it's really important that we don't worry about that sort of thing right now. When you have to choose a variable, I would suggest you just choose an A, a B, a C, or a D, just for now. Here is one of the most famous equations. You see this in cartoons. People talk about it. It was put forward by this guy here, Albert Einstein. It says E equals mc squared. Now, each one of these variables, see, I keep using that word variable because it comes from the word vary, which means change. Each one of those represents something. The E represents the amount of energy in joules. Joules is the unit that we use to measure energy. M is the mass of the body that you're talking about in kilograms. C is the speed of light in meters per second. You can go and look that up. And speed of light is always the same. So what we have here is the amount of energy in a body is equal to its mass times the speed of light squared. Now, that's just a little explanation. You don't have to be able to do it. But I'm just showing you that algebra is at work in physics all the time. Here's another one. Famous guy, Isaac Newton. He did a lot of work looking into gravity. Famous story that an apple fell out of a tree on his head, although apparently that didn't really happen. He developed what is called Newton's law of universal gravitation. It looks like this. Now, it looks more complicated than the one before. It isn't, because the one before, Albert Einstein's E equals mc squared, is actually a very different type of mechanics to this. This is what we call classical mechanics. We still use this formula today to calculate the force of gravity that exists between two bodies. And what Isaac Newton said was that the force of gravity between two bodies will be equal to G, and G is known as the gravitational constant. You can go and look it up. It never changes. It's always the same value. And then M1 and M2. Now, this is what I wanted to show you. Can you see that they have put, instead of putting X and Y, they've put M1 and M2, because these two talk about mass. That's the mass of the first body, and that is the mass of the second body. So one of the bodies could be your body, and you could make this the Earth, multiply them together. And it's divided by r squared. R is the distance between the center of mass of the two bodies. And you don't have to worry about that, just for interest's sake. In physics, for distances apart, they often use r. So in this algebraic formula, they've used M1 and M2. Some of them, some formula, they put a lowercase m and then an uppercase m to show that there's two different. All I want you to take from that is you can make anything a variable virtually. Okay, I want you to pick a number, any number. But I don't want you to pick any number like you used to do in the past, where I picked 27 and think of it in your head. When I say pick a number, any number, I want you to think of something like X. X could be any number. How much is X? I don't know. I haven't told you. You haven't told me. Nobody's told us. It changes. It depends where it is. You could have chosen Y. The only difference is Y may not be the same as X. It may be. Sometimes it is. But yeah, there's Y. Z. You could have chosen Z. You could have chosen T. Very often in physics, we use the variable T for time. A. Sometimes that is used for acceleration in physics, the letter A. All right. So all I want you to take from that is you can represent something that changes by any letter, just a random letter, or sometimes you can choose one that helps you remember what it is. We're going to just work through a few examples here. So I want you to think, if I asked you to write down 3 times a number, but I don't tell you what the number is, I want you to write down an expression. Notice I say expression because there's no equal sign in this. Just write down in an algebraic expression 3 times a number. Now, do you agree that would work? 3 times any number. I hope you agree, because that's fine. You could also write it like that, but it's normally better if they say 3 times a number, do the 3 first. Now, this is really important. 3 times y, or y times 3 in algebra, is written as 3y. We leave out the multiplication sign. Remember, I told you in algebra we try to get rid of division signs and multiplication signs. So 3 times a number is 3y, or you could have had 3x or 3q or 3p. So remember that 3q, 3n, 3b, 3x. Okay, and try something else. A number increased by 6. A number increased by 6. Think about that. What could we write? A number increased by 6. Well, I chose x plus 6 because I'm old and boring. x. You can put brackets around that. It looks better and neater. It's often a good thing to do, but we're more about that later. Y plus 6, or y plus 6 like that. F plus 6, or f plus 6 like that. J plus 6, or j plus 6 like that. Right, next one. A number decreased by 20. A number decreased by 20. Think about that. What could you put? A number decreased by 20. Again, I've gone for x minus 20. I could have used any variable there because I just said number, any variable. So that algebraic expression here is a number decreased by 20. And you can put brackets around it. New one. A number increased by another number. Think about this. A number increased by another number. Okay, here we go. X plus y, or a plus b, or a plus t, or b plus g. As long as you've got two different letters there, that is one number increased by another number. And of course, you could also have it in brackets, but you don't need to in this situation. Right, whoa. I jumped ahead a bit there. Two numbers multiplied together. X times y. Now, remember what we said before. We try and get rid of multiplication signs and division signs. We put it in brackets, but that's the best way. Two numbers multiplied together. X, y. A number plus 3 times another number. A number plus 3 times another number. A number plus 3 times another number. But remember, could have put it in brackets, you don't have to. We did say we try and get rid of multiplication signs. So a number plus 3 times another number. A number divided by another number. Me, boring again. X divided by y. You all agree? Or in brackets. But we try and get rid of division signs. So x divided by y is a number divided by another number. And you should know this from your fractions knowledge. Right? A half is 1 divided by 2. A third of a number divided by 3 times another number. A third of a number divided by 3 times another number. Well, think about that. We will have some examples to do at the end. How would you write a third of a number, and how would you write 3 times another number? Well, a third of a number, I take that number and divide it by 3. That's a third of a number. Divided by 3 times another number. Now we've got 2 division signs there we want to get rid of. Here's a third of a number, x divided by 3. And now we've got divided by 3y. I'm going to leave this one like this because it becomes a bit complicated. But what you would actually do is take the 3y and put a big line under the first fraction and put the 3y below that. But that's okay. We'll leave that one like that for the moment. The square of a number plus the same number. The square of a number plus the same number. Now, obviously, you need to know what is meant by the square of a number. That means you multiply the number by itself. So the square of a number plus the same number. So that would be x times x plus x. Right, x times x is like that, but in algebra we don't write it like that, we write it as x squared. So a number times itself plus the same number, x squared plus x. A number times itself times another number. A number times itself, x times x times another number, y. And I'm sure you spotted it already. there are two multiplication signs you want to get rid of. X squared times y. So the x times x becomes x squared. And remember, let's get rid of multiplication signs, x squared y. So that means x multiplied by itself, multiplied by y. A third of a number times itself. So you could read these differently. You could read it as a third of a number times itself, or a third of a number times itself. The one I'm looking at is a third of something. What is that something? A number times itself. Well, wouldn't you say a number times itself is, oh, look, I've chosen an n, not an x. N times n. And to get a third, we divide by 3. So n times n becomes n squared and divided by 3, rather than write it like that. A number times itself, and to find a third, I just divide it by 3. Right. If that was a little bit confusing and you'd rather watch it again before trying the examples, do that. You need to get ready with pen, paper, board marker, or a whiteboard or something like that. If you are ready to carry on and you just need a breather, go and have a breather, get some oxygen into your brain, have something to eat or drink, and then sit down. What we'll do is I'll put an example up on the screen. I'll ask you to pause the screen pause the video every time, and then carry on when you're ready. Okay, so either go back to the beginning and watch again if you're not 100% sure yet, or continue from here. Right, here we go. 4 times a number increased by a half of itself. 4 times a number increased by a half of itself. Pause the video, continue when you're ready. Right. 4 times a number, and you could use A, B, C, D. It doesn't matter. I have X. You can use anything. Plus, for increased, a half of itself. So you've got to use the same letter here. You need the same variable because it's of itself. How do we find half of itself? X divided by 2. Now that looks all right, I suppose. We could take the brackets away because the order of operations keeps them all nice and together for us. 4 times a number increased by half of itself. 4 times x should be written as 4x increased by x over 2. Right, next one. A quarter of the sum of two numbers. A quarter of the sum of two numbers. To do this one, you need to understand what the word sum means. The sum of two numbers means what happens when you add them together. All right, so a quarter of the sum of two numbers. Pause the video and resume when you're ready. Right, there's the sum of two numbers, x plus y. And I divide the whole lot by 4. You could do it like that, because it's not necessary to have the brackets, but if you have them, that's great. Right, so there's the sum of two numbers, and to get a quarter of that, we divide by 4. 3 numbers multiplied together decreased by a half of the third number. 3 numbers multiplied together decreased by a half of the third number. Pause the video, resume when ready. Right, 3 numbers multiplied together, x, y, z. You could have a, b, c, d, g, q, as long as they're 3 different ones. Then you need a minus sign for decreased. Then you need this variable to be the same as that one, because it said a half of the third number, z over 2. You might have had divided by 2 here, but remember, this is the way we write them in algebra. Okay. A quarter of one number multiplied by the square of a second number. So you've got to be careful how we read this. I've put a colon there so that you don't confuse it. So it's not a quarter of one number. It's a quarter of one number multiplied by the square of a second number. Pause the video, continue when you're ready. Right, there is one number multiplied by the square of another number. I suppose you could have had x squared y, but the way it was worded, this would probably be better. Any two letters here, you could have the square on the first one. This is better. And then to find a quarter of that, we divide by 4. The square of one number multiplied by the square of another number divided by the sum of the same two numbers. Now, be careful, this comma here tells you we don't want the square of another number divided by it's the square of one number multiplied by the square of another number, all of that divided by the sum of the same two numbers. Right, go for it. Pause the video, resume when you're ready. Right, there's the square of one number, and you could have used any variables you like. I'm going to just use x and y most of the times. Multiplied by the square of another number, divided by the sum of the same two numbers. Right, there's the divided, and there's the sum of the same two numbers at the bottom. The sum of two numbers decreased by the sum of two other numbers. The sum of two numbers decreased by the sum of two other numbers. Pause the video, resume when you're ready. X plus y, the sum of two numbers, decreased by the sum of two other numbers. You may not have put the brackets in. It's better to put them in because of the way it was worded. Right. The sum of two numbers divided by the difference between two other numbers. The sum of two numbers divided by the difference between two other numbers. Pause the video, resume when ready. Right, there is the sum of two numbers divided by the difference between two numbers. Now the difference, whenever you hear the word difference, that means one number subtracted from the other. As you know, we try and get rid of divide signs. The sum of two numbers divided by the difference between two other numbers. And that's with brackets. You don't really need in this example, but if you did have them, perfect. The sum of two numbers multiplied by another number. The sum of two numbers multiplied by another number. Pause the video and continue when you're ready. Right, there's the sum of two numbers, x plus y, multiplied by another number. I've chose z. Now, remember we said we always try and get rid of those multiplication signs. This might look weird to you, but it can be done in algebra. We can go x plus y and just take the multiplication sign away. By the way, guys, if you put x plus y times z without the brackets, it's wrong, because that would mean y times z happens first, and the x would not end up being multiplied. So in this example, you would have to have the x plus y in brackets. We put the z there, but normally we write it like that. So the sum of two numbers multiplied by another number. The product of two numbers decreased by the quotient of two other numbers. Right, the product of two numbers, the product is the answer you get when you multiply two things together. The quotient is what you get when you divide two things. So the product of two numbers decreased by the quotient of two other numbers. Pause the video, continue when you're ready. Right, there's the product of two numbers, a times b, decreased by the quotient of two other numbers. Now, you know there are multiplication signs and division signs that we can get rid of. You could have written it like that, it would be fine. Right, the product of two numbers, a times b, decreased by the quotient of two numbers. And notice I've used A, B, C, and D here. You could have used 4 different variables, whatever you like. Just don't make life difficult for yourself. Twice the sum of the squares of 2 numbers. Now, it's the language. Twice something. Twice what? The sum of the squares of 2 numbers. So do the squares of 2 numbers first, and then work out how to do double that. Pause the video, continue when you're ready. Right. Here is the sum of the squares of 2 numbers, e squared, f squared, and I add them together. So that's the sum of the squares of 2 numbers multiplied by 2. Just so, because we said twice, remember, we try and get rid of multiplication signs. It looks like that. Twice, that 2 gets multiplied by this whole bracket. 3 times the sum of 2 numbers divided by the difference between the squares of 2 other numbers. Right, 3 times the sum of 2 numbers divided by the difference between the squares of 2 other numbers. Remember, you can choose any variables you like. Pause the video, continue when you're ready. Right, 3 times what? The sum of 2 numbers. Well, x plus y is 2 numbers multiplied by 3 and divided by, there's my big divided thing there, the sum of the squares of 2 other numbers. Oh, sorry, the difference between the squares. Difference between the squares of 2 other numbers. I've chosen a and b. I don't care what you use. There's the square of a and the square of b subtracted from each other. 3 times the sum of 2 numbers divided by the difference between the squares of 2 other numbers. That's also okay, but you don't need that. A third of the square of one number increased by the product of 2 other numbers. A third of the square of one number increased by the product of 2 other numbers. Pause the video, continue when you're ready. Right, a third of the square of one number. Well, there's a square of one number. I chose a. And to get a third, we divide it by 3. So the first term here is a third of the square of one number increased by the product of 2 other numbers. Remember, product multiply together, b and c. Right, so you would need 3 variables in here, one there, and one there. Okay, if you didn't quite get that, watch the tutorial again. And again, even if you struggle with these, it's more about the language. The tutorials that follow are actually easier, and they might even help you understand this. A lot of this has to do with language, but it's also about how do you write a times b? It's ab. How do you write a plus b? You can't get rid of the plus sign, so it has to be a plus b. X minus y has to be x minus y. X divided by y is x over y. Right,